Hello everyone. Welcome to the Getting Ready for Disaster with Chaos Engineering. I myself, Sunit Parekh from Thoughtworks Pune office, and I have with me.
Hi, I'm Prashanth from Thoughtworks Chennai office.
We both are very excited about presenting you all the work that we have learned on the projects in last year and so. We started looking into chaos engineering since we picked up site reliability engineering from last one and a half year. And as part of that, we deep dive into how we can make our site more reliable, more resilient, and make it highly available. Let's first look at what we are going to cover in this session. We'll start with why we need chaos engineering. We'll look into what is chaos engineering. We'll learn how to build resilient system using Litmus as demo, and then we'll conclude at the end.
So let us look into why are we even looking into this topic? So I have a couple of examples which have happened in production. So one of our e-commerce clients had a checkout systems which calls an order API, which in turn calls a payment API to make payment. The payment system calls internally the payment gateway to make the payment. So whenever there is a heavy load on the payment gateway system, which is at the bottom of the line of the system, we observed increased latency. This increased latency would cause a cascading ripple effect all the way to our checkout systems. So this is one of the scenarios which we faced in production. And there is another one which is very common, which is so Black Friday is one of the most high traffic seasons due to discounts offered during that period of time. Every year before Black Friday, we used to run load tests to see if our systems are able to withstand the load we are anticipating. To facilitate this, we built a load test tool on top of Vegeta. And the interesting thing this year was that we wanted to run the load test for the entire day to see if our systems were able to handle the sustained load. The concept of running for the entire day was a bit new. Everything was running fine until the load test tool kept on crashing after an hour of run. It's kind of ironic that the load test tool is not able to run for a long period of time. So we dug deeper to find out that the root cause was that the tool which we built was writing logs into itself and it kept running out of disk space. So let us deep dive into see how we can prevent these kind of situations.
Now, to understand chaos engineering better, let's first look at what is chaos engineering, right? Chaos engineering is like a vaccine, which helps you to prevent disasters in production, which helps you to build resilient system and improving your resiliency by testing all the different scenarios which can go wrong in the production, which generally you are unable to reproduce in the normal setup or normal development cycles. Some examples of chaos engineering and chaoses are: the first, your CPU and memory spikes. They go beyond expected limit, and then we want to see what happens to our overall system. Second one is the network latency. Nowadays, microservice architecture is very common. When one service is calling another service, the next service is calling the third service, and the example that Prashant shared, right? So what happens if you have a high network latency suddenly for a very short period of time? Another one is the time travel. What happens when you have a daylight saving? What happens during the peak load and all that, right? Another one, application crashes due to some bugs, memory leaks, or any other problem into the application. Now, how our overall system behaves under that situation. And the last one, which Prashant already shared, is the very common disk space filling out. I'm sure you must be wondering that how many times all of us have faced this same issue, and because of that, the system went down. How our system is able to cope up to such situation is important. What is our mean time to recovery is important, right? If system fails, how fast we can go back to the normalcy is what all about chaos engineering. These are just 5. You can have hundreds of types of chaos, and they are supported first class in today's modern age tools.
So let us look into how we do these kind of chaos testing. So to start, let me go into available tools which are there. There are both paid and open source tools available in the market. So Netflix as a company, as most of you would be aware, was one of the first companies which popularized this kind of chaos testing and came up with their tool called Chaos Monkey. So soon the idea spread and there were multiple alternatives like Chaos Toolkit, Litmus, and Gremlin. So Gremlin is a paid alternative for people who are looking for enterprise support. So Litmus is a really cool tool which treats Kubernetes as a first-class citizen, and we'll be demonstrating using Litmus in this talk. So let us deep dive into steps that we follow for chaos testing. So there are majorly 4 steps. The first step is to define a steady state, which means defining how an ideal system would look like or would work like. For a web application, the home page is returning a success response. For a web service, this would mean that it is healthy or returning a success in their health endpoint. So we first define the steady state, how it should look like. Following which, we will introduce the chaos. What do I mean by this? Is that we simulate a failure such as a network bottleneck or a disk fill or a latency or something of that sort. Following which, we verify the steady state, which is the state that we defined in the step 1. In this step, we verify the steady state, which means that we check if the system is working as expected, even after the chaos is working. The last step is rolling back, which is the most important step, is that we roll back the chaos that we caused. So if this test passed, then great, your system is working as expected. If your test failed, what we would do is we can follow a blue-green refactoring. Since we have identified a weakness, we fix it and then we run the test again. So during this entire life cycle of the chaos testing, what we do is we continuously monitor how the system is behaving. So observability and monitoring is very vital here. So chaos testing is usually done in production, as the infrastructure is slightly different from the other environments and certain scenarios occur only in production, but it needs to be taken with a grain of salt. We don't want to destructively bring down our production systems completely, but rather learn from the system weakness by introducing chaos to understand the weakness. The key aspect is to have proper observability and monitoring so that we identify the different aspects of the infrastructure that is failing.
To see all of this in action, we have very good demos lined up for you. But before we jump into the demo, let me first tell you the application that we are using for the demo. This is the classical BookInfo application written by the service mesh, Istio service mesh people. So let's look at that first. So in this BookInfo application, we have the main page, which is a product page, which is written in Python, followed by the product page calling to product details to get the product details as another microservice, which is written in Ruby. Then we have the another service, which is called product reviews. But for this, we have 3 different versions: reviews 1, reviews 2, and reviews 3. These all 3 versions of review service is written in Java. You have review 1 with no rating, review 2 with rating in black color, and review 3 in rating with red color. Now review service makes a call to the rating microservice, which is written in Node.js. So now if you see this application, it is having 4 microservices written in 4 different languages. And when we deploy this application, we are going to deploy with the Istio as our service mesh. So you will see the sidecar also, and with the sidecar, we'll get a lot of telemetry information and visualization, observability. Monitoring is vital, so we need to have that in place. So all that is available in the setup that we have. Let me just show you this application working now. This is my terminal window. Let me just explain you quickly what I have. So if I do kubectl get nodes, I'm using Docker desktop on my local machine. So Kubernetes is running as part of the Docker desktop setup. I have a single node cluster running here, which is running version 1.21. Let's look at what I have in the Kubernetes Istio system namespace. I have all the Istio component running. The Istio main Istio binary Istio D is running, and I have all the other monitoring system in place in the same namespace, like Kiali, Grafana, Prometheus, Jaeger, all of that. If I go to look at my BookInfo application, so I have deployed my BookInfo application with Sidecar. Let's look at my BookInfo application now in the default namespace. So I'm just looking for the kubectl get pods, and I have all the pods that I have just showed you in the BookInfo application. So I have my main application, which is product page, followed by details page, followed by 3 versions of reviews and a rating service. All of this is running inside my Kubernetes cluster now. I have a port forwarding setup for my Grafana dashboard. I have Kiali setup again, and that is port forwarded in my local machine. And my main application, which is product page, I'm doing a port forwarding again here to 9080. I have this window where I'm going to hit my application with lots of concurrent requests. Okay, let me show you my application running first. So if I go to the browser and if I hit a page localhost 9080, I'll see this application, which is running, bookstore application running here. I have 3 kinds of review service, right? No rating, black rating, red rating. So if I keep doing the refresh, you'll see the rating change, right? Which means it is running on my local machine perfectly fine. Now, let me generate some load using Hey. So now we are generating concurrent load onto the application. Let's go and look at Kiali. So now you'll notice that my Kiali is showing all this setup with all the details into it. So if I look at the product page, hitting product detail, and it is responding in 11 milliseconds. Product page hitting the review service, and the load is distributed across 3 versions of the review service, and all of them returning in some milliseconds, right? Single digit milliseconds. And then version 2 and version 3 of the review service hitting the rating service here. And that's how the whole application works. Let's look at how we can set up the Litmus chaos toolkit into our cluster and run some chaos. The first experiment that we'll do is related to network disruption, and we'll add latency to our rating service, and we'll see how the application behaves in such scenario. So the first part to get the Litmus running is to set up the Litmus, right? So we have to add operator to set up the Litmus. To add operator, it is simple kubectl apply and add the operator YAML. You can use YAML as well, but to keep it simple for this session, I'll just do the kubectl apply. You'll notice that all the components are installed and unchained because I've already installed it for you. Let's see if it is running or not. You can notice that chaos operator is running in my Litmus namespace. So now this operator is responsible for executing your experiments or chaoses into the system. The first part that we have to do to get this chaos setup is to add experiment that we want to run. So in our case, we want to add the network latency. So I'll add network latency experiment. I'll say kubectl get chaos experiments, and I'll see my pod network latency experiment added. Second step we have to do is set up a service account so that this experiment can run in your namespace. Do that again. There is a YAML available. You can apply this and it'll create a service account with giving the proper access rights so that the experiment can run in your namespace. Remember that I am applying this experiment and the service account inside my default namespace where I have my BookInfo application installed. Now I have the setup done. Now the next step is to actually inject the chaos, right? And to do that, they have another component called chaos engine, which is the actually deploying the chaos. To do that, in Kubernetes world, always follow YAMLs. So there is a YAML to add the network delay. So this is the new kind, which is called chaos engine. We have given a name BookInfo network delay to this. There are default settings that I've kept. The important setting is here, where I say that I want to inject a network delay chaos to my application with label app ratings. And it is a type deployment. So I want to add to all the pods. Now there are further fine-tuned settings available. If you have different network setup, you can configure that. Mine is default, so it is ETH0. The network latency that I want to add is in milliseconds. So I'm adding 2000 millisecond, which is approximately 2-second network latency. So when a review service makes a call to rating service, it's going to be 2-second delay there. I'm going to run this chaos for 100 seconds. I can run for longer duration also. I want to affect all the pods with this chaos. You can manage also that only 20% of the pod affects this network, and then you can see how your application behaves under such cases as well. Simple setup. Again, if you are in the Kubernetes world, this follows Kubernetes native approach to set up chaoses. What I have to do, you might have guessed it for now. kubectl apply -f network delay engine. I'll just apply this. But before that, let me start putting some load onto my application, right? So I'll increase this time to 200 seconds. So it will run for long duration. It is started. So load is getting generated. So now let's go and look at Kiali if my application is running. And you will notice that it is in last 1 minute, all green. Now let's introduce chaos. Let's watch what happens in the pods as well. So you'll notice that there are new pods coming up. Like I have the pod network latency pod, which is going to inject the latency. And now I have another pod, which is helper to it. These are internal to Litmus tool that we are using. And we are continuously generating the load. Let's go and look at Kiali, what's going on there. So you will notice that now there are some errors due to the delay and the network delays, right? But the errors are between review service and the rating service, right? And when there is a delay, it's not healthy. It starts showing up as yellow in the Kiali dashboard. If I refresh again, we should see that this time that the review service takes to respond is going to be around 2 seconds, which is the delay that we have added. It takes the average response time. So it takes time to refresh here. Now you see 2 seconds delay or 2 seconds for my review service. If I go to the application is still working fine because this 2-second delay is my application can handle and everything working fine. See? So I have built the application which is resilient enough under the latency from different services. And that's how you can do your testing around all the chaos, network related chaos. So my chaos experiment is still running, just completed, and my load is still going on the system. So you see that the experiment is completed after almost 2 minutes. If I go back to clearly, you'll see there are red because of the errors in the response due to delay, all that stuff. You can see that the traffic was increased during this time. And now, again, after the chaos was over, everything is fine. If I change the timeline here to 5 minutes, you'll see red. But in last 1 minute, no errors or no delays because chaos completed. So that's about the network chaos that we added into our system, and we checked our system that it is able to cope up to the network delay of 2 milliseconds from the rating service, and all good. So now let's look at another chaos. The second chaos that we'll look into is disk fill. So we are going to fill the disk of the product page application, which is the main application, and you will see that there are errors now.
So for the second demo, we will look at the disk fill. As Sunit mentioned, we have the same identical setup on Docker for desktop, which runs Kubernetes on top. And let me just quickly show you that I have the similar setup. So I have all the different microservices running, which was already shared. And the service is also up and running. So I already have some base things set up. For example, the disk fill experiments is already applied and it is available and ready to use. So for the disk fill, what we will do is we will introduce chaos by trying to fill the disk of the product page. So let me quickly show you how the disk fill chaos is going to be injected. So here is the disk fill chaos that we are going to introduce. So if you see, we have given it the name product page chaos, which we will be targeting the product page. So as Sunit already mentioned, we will, so Litmus looks at the app label. So we have tagged it with product page. So this will be targeting the product page. And we will be trying to fill the disk. So there are other configurations which we can see. For example, the total chaos duration will be for 65 seconds. And the fill percentage, which is in this case, we are going to try to fill 100% and see how it disrupts the flow. And since we are running it on Kubernetes for Docker, we'll set the container path to be bare with Docker containers. So we also have a probe which keeps checking for how the product page is responding, and it will continuously probe for every 5 seconds. So we will be primarily targeting the ephemeral storage, which is being used by the product page. So let me quickly jump into that before I show you the demo. So the product page uses an ephemeral storage of 2 MB, which starts with 2 MB and it goes all the way till 5 MB. And we have a mount, which is the /temp. So let us actually introduce this disk fill chaos and we will try to look at what happens. So we will be primarily monitoring the product page. So I'm going to apply this disk fill .yaml, which we just saw. And we'll also be monitoring the product page disk usage. So let me do exec and I will do a df. So this will show me how much space I'm using. So this 16% might not be, this would show the entire disk, but the ephemeral storage, you will see the numbers changing here as the disk fill starts. And I'll also monitor what happens to the pod via kubectl events. So I'm going to grep based on this. Sorry about that. Yes, so I'm monitoring what is happening to the kubectl pods. So if you see, you'll see that what happened with the pod is that it started, you see the different events. So now let us start the chaos. So if you see that it started and Let me do a watch of the pods. As with the previous demo, we'll see that the disk fill has started running, and you also see a product page chaos runner, which is also running. And this will in turn create a disk fill helper. So now the disk fill helper has started doing its job. So you'll see that here the used and the available space will keep getting filled. It will keep getting changed. So once the disk fill completes, you'll see what would happen to the product page. So ideally, what we're trying to simulate is similar to the first production issue which we faced, which is where the log was overloading in the pod. So I think now the chaos has already caused some destruction, which you should see here. You should see that it is no longer able to poll the pod. And in the events is clearly mentioned. You'll see that after a certain point, it stops the pod. And the reason being the pod ephemeral local storage exceeds the limit and it kills the pod. So Kubernetes being Kubernetes, it spins up another pod because it needs at least one replica according to our initial setup. So this is one of the kind of chaos which we wanted to see, which we wanted to demo it for you. Right. So since we saw how the disk fill chaos worked, we can also look at what happened with the chaos engine to see what all steps we covered. So let me go into this and let me zoom in a bit so that you can see. So I'm going to describe, this is the name of the disk fill chaos engine that we just injected, which we saw in the, which we saw the code here. So I'm just going to quickly describe this so that we see what all happened. So if I do describe, you'll see that here the different events which happened with respect to the chaos engine, which is first it initialized, it did a experiment job create, and then it did a pre-chaos check, which going back to the 4 steps of chaos, it did a prerequisite check, which is the steady state condition, and then it injects the chaos, which is actually running the disk fill chaos on the pod, which we have labeled. And post that, it causes it checks the steady state again, and then it rolls back. The last step would be it would have the summary, and then it would do a cleanup of the job. So we also see the status of the chaos engine, that it is completed and the verdict to be passed. We see the verdict to be passed because Kubernetes restarted the pod. Let me quickly do that. I'll show you that. So if you see here, the product page v1, again, Kubernetes controller restarted the product page because it went down as it exceeded the ephemeral storage.
Wonderful. We have seen a couple of demos now, how the Litmus works inside Kubernetes and introduces chaos. The first one was network disruption. Second one was disk fill. Both of these are quite common problems that we see in production. Now you can apply this on your project. So remember 4 steps for chaos testing. Step 1, define your steady state hypothesis. Make sure it is working. Step 2, introduce chaos. See what happens, how your system behaves under chaos. Step 3, verify steady state and all the system behavior that it is working fine, and roll back. Remember, monitoring is vital for all this testing, and you have that set up, right? We have seen how Kiali helps to know how my system behaves under such load, correct? Now we have showcased you the Litmus tool. Let me talk a little bit more about that. So Litmus Chaos is the website where you can find all this. If you want to know all about experiments and documentation, they have very good documentation. We have been learning from just the documentation here. You can look at the list of experiments available. As I said, there are hundreds of chaos experiments available. They have all of this meant for Kubernetes. Just the only one thing that you have to remember working with Litmus Chaos is that it is Kubernetes native. If you want to introduce Chaos into AWS and all that, you can leverage tools like Chaos Toolkit. You can go for the commercial one, which is Gremlin, very powerful leader in the industry. You can use all of that. And the documentation provided gives you full detail about all the options available, how you can configure, what you have to do. Okay, let me conclude with giving you the benefits of using chaos engineering. And this is two of the topmost benefit that has been reported in the state of chaos engineering report. Those companies who adopt chaos engineering have seen increased availability in their application. 99.9% availability for the application for the teams running chaos experiments. They see reduced mean time to recovery. It's like if application fails, how fast you can bring them up. You can practice that also with chaos engineering. And companies have seen 23% MTTR under 1 hour and 60% under 12 hours. So these are great benefits for you to start adopting chaos engineering in your applications.
I hope you take this as an opportunity to include chaos engineering practices as part of your DevOps pipeline. So we are signing off. Hope you had an informative session. Thank you.
Thank you very much.